Hello and welcome to part 2 of our lesson on rational functions from section 8.5 in our text. We're going to pick up where we left off looking at examples from the textbook. So our next example, number 37, the instructions ask us to find the x and y intercepts, the asymptotes, the domain, and the graph of the function. So we have a lot of stuff to find. Let's start with the easy stuff first. Remember, to find the domain, you set the denominator equal to 0 and solve. That's also the way you find the x-intercepts. So we're going to take the denominator, set it equal to 0 and solve. We're going to bring the 1 over, and that gives us x equal -1. And that would be our vertical asymptote. Now that is also the restriction on the function. X cannot be -1. So then to write the domain in set notation, we would say the domain is the set of all x such that x cannot be -1. Since there is a vertical asymptote at -1, that means the graph cannot exist at -1. But it can exist everywhere else, just not at -1. So there's your domain in set notation. If you need that in interval notation, it would be everything from -infinity up to -1, not including -1, jump over to the other side of -1 and keep going. So there is our domain in both set notation and interval notation. The next easiest piece to find probably would be the horizontal asymptote. So to find the horizontal asymptote, you have to compare the degree of the top to the degree of the bottom. Here, the degree of the top is 2, and the degree of the bottom is 1. So this would be the case where the degree of the top is greater than the degree of the bottom, and that implies that there is no horizontal asymptote. So since there is no horizontal asymptote, we might want to check and see if there is a slant or oblique asymptote. For that to exist, the degree of the top has to be greater than the degree of the bottom by exactly 1. And 2 is bigger than 1 by exactly 1, so there will be a slant asymptote. And to find our slant asymptote, we're going to need to do long division. So setting up our long division, the first thing we need to know is, what would we multiply x by to make x squared? Well, that would be x. And then that x is going to distribute to the divisor. X times x gives me x squared. X times 1 is x. And then we need to draw the line, change the signs, and then combine. -4x minus x, that's going to be a -5x plus 3. And then we're going to ask ourselves again, what would I multiply x by now to make -5x? And that would be -5. And you don't have to finish this long division. We now have enough information to know that the slant asymptote is going to be y equals x minus 5. That is the answer for our slant asymptote. Now, before we get to the graph, we also need the x-intercepts and the y-intercepts. And so we're going to make a table for that. And remember, to find your y-intercept, you let every x be 0. So basically, finding the y-intercept means that you need to calculate g of 0, which would, well, basically eliminate every x term in the function. So if I show the work, that would be 0 squared minus 4 times 0 plus 3 all over 0 plus 1. And the zeros all go away, leaving us 3 over 1, which is 3. So there is our y-intercept. Then to find the x-intercept, or intercepts, we need to let y be 0. And remember, g of x represents y. So we're going to set this fraction equal to 0 and solve. So now I have the function set equal to 0, and I need to solve for x. So the first thing I'm going to do is I'm going to get rid of this fraction by multiplying by the denominator. And whatever I do to one side, I have to do to the other. However, 0 times anything is 0. So that side is still going to be 0. On the other side, the x plus 1's cancel, leaving us a standard trinomial, a quadratic equation that we can solve by factoring. So to factor the standard trinomial, we're going to use parentheses, we're going to read the signs, and we're going to fill in the blanks. Now, I do need numbers that multiply to make 3, that also add and make 4. And -1 and -3 multiply to make +3, and add to make -4. So that's factored correctly. Now I can set each factor equal to 0 and solve. Moving the -1 over gives us x is 1. Moving the -3 over gives us x is 3. And then we need to list those as ordered pairs. So our x-intercepts are going to be 1, 0, and 3, 0. At this point, I have all of the information they ask for that would be required to give us an accurate graph. So we have our x and y intercepts. We know that there is a slant asymptote and a vertical asymptote. Let's go and sketch the graph of the function. X equal -1 means we're going to go to -1 and lay in a dotted line that's going to represent our vertical asymptote. Next, we need to sketch the graph of the slant asymptote, which means you need to know how to graph a line, and I'm going to use the slope-intercept method. So we're going to plot the b first. 1, 2, 3, 4, 5. Plot the b, and then we're going to rise and run. Now our slope is 1, and 1 over 1 is 1. So that gives us a rise of 1 and a run of 1. And then we're going to lay in another dotted line, and that is going to represent our slant asymptote or our oblique asymptote. And then we're going to plot the intercepts. So 0 and 3, that is our y-intercept. 1 and 3 are our x-intercepts. And so what I know at this point, I know that the graph has to be contained within the asymptotes. You see, the asymptotes are like fences. So I've got 1, 2, 3 points in this region. So that means that the graph is going to be contained within this region. It's going to have to approach the asymptotes, but also go through these points. So it's going to look something like this. Approaching the asymptote to the right, and approaching the asymptote coming up, and then I simply need to connect the dots through something like that. So that gets half of the graph. Now the other half of the graph is going to be on the other side of the vertical asymptote. So it's either going to be in this area or in this area. It's got to be in either the top or the bottom. Let's call that fields. Since we're pretending like the asymptotes are like fences, then this is a field, and then this down here is a field. And we're going to have to know where the graph goes. Now, the way we're going to do that is we're going to look at an x value to the left of the vertical asymptote, and it'll tell us if it's in the top field or the bottom field. So going back to our table of values up here, the x value that I want to look at is -2, because that would be to the left of the vertical asymptote, and I'm going to need to find the y-coordinate, which means I need to plug that x into the function. In other words, we're going to calculate g of -2, and that's going to give us -2 squared minus 4 times -2 plus 3 all over -2 plus 1. And the easiest way to calculate that is with the Casio. So we're going to hit clear. We're going to start with a fraction, and we're going to do -2 squared minus 4 times -2. Notice that negative numbers have to go in parentheses. That is absolutely important. And in the denominator, -2 plus 1. And we get a value of -15. So that means we have the ordered pair -2, -15. If we plot that on our graph, we're going to have to go all the way down to -15. So this is -6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Down here at -15, we're going to have the ordered pair of -2, -15. So about there. Now what that tells me for sure, it tells me that the graph is going to be in the lower field. If I want more definition, I could do more x's like -3, -4, -5. But I'm just going to estimate at this point, extending my asymptotes just a little bit. We're going to estimate that the graph is going to do something like this. Curve through, remember it has to approach the asymptotes and go through the points we plot. And again, if you want to know for sure like how high this goes or how close it gets to the asymptote, you can do more points. But it's going to do something like this in this lower field. At this point, we've answered the question, providing all of the information they asked for. What I'd like to do now is check with Desmos. So I already have the function pulled up in Desmos. The first thing we're going to check is the vertical asymptote, x equal -1. And if I scroll out a bit, you're going to see that that does fit nicely within the curve. The green graph approaching the vertical asymptote left and right. And if I go back to the standard view, the next thing I want to check are the intercepts. So clicking on this graph, I can see that there is a y-intercept of 0, 3 and x-intercepts of 1 and 3, just like we came up with when we did the work by hand here. Our x and y intercepts are verified. And you can see that this graph does go a little bit below the x-axis the way we sketched it here. Now, as far as the bottom curve, again, if I zoom out some, you can see that this bottom curve does come up and down. I probably need to check the slant asymptote as well. So that was y equals x minus 5. And you can see that the slant asymptote again fits nicely within the curve. And I believe that that verifies everything that we did by hand. So that's going to do it for this example. Next, number 55. This will be the last example in our lesson. Here we have a rational function, and they want us to repeat what we did in problem number 37. So we're going to find the x and y intercepts, the domain, all of the asymptotes, and then sketch the graph of the function. Again, we're going to start with easy stuff first. Vertical asymptote, super easy. You simply set the denominator equal to 0 and solve. So x plus 2 equal to 0, when I move the 2 over, gives us x is negative 2. And that's it. That is our vertical asymptote. Now that is also going to give us our domain. So the vertical asymptotes are going to be the restrictions on the function. The domain in set notation is going to be the set of all x such that x cannot be negative 2. Because if there's a vertical asymptote at negative 2, the graph cannot exist there. So there's our domain in set notation. If you need interval notation, again, that's not that bad. That's minus infinity up to our restriction. Parenthesis means negative 2 is not included. And then we skip over to the other side of negative 2 and keep going. So there's our interval notation and our set notation for the domain of the function. Next, let's find the horizontal asymptote. Now, to find the horizontal asymptote, you have to compare the degree of the top to the degree of the bottom. Here, the degree of the top is 1, and the degree of the bottom is also 1. So when the degree of the top equals the degree of the bottom, that implies that our horizontal asymptote is going to be y equals n over m, where n is the lead coefficient of the top and m is the lead coefficient of the bottom. So this would be 1 over 1, which is 1. So our horizontal asymptote is going to be y equals 1. Next, let's find the x and y intercepts. So with our chart here, finding the y-intercept, we're going to let x be 0. Plugging in a 0 for the x's is going to give us 0 minus 1 over 0 plus 2, which would simplify to negative 1/2. So there's our y-intercept. Then to find the x-intercept, or intercepts, we're going to let y be 0. F of x is y, so we're going to set this function equal to 0, and then we're going to solve for x. And the first step is to get rid of the fraction. So we're going to multiply both sides by x plus 2. 0 times anything is 0, so that's still 0. These cancel. And then moving the minus 1 over tells us that x is 1. And that is our only x-intercept this time, 1, 0. Now, what I may not have said anywhere in this lesson at this point, I'm about to say, and this is important, if you have a horizontal asymptote, you cannot have a slant asymptote. And vice versa. If you have a slant asymptote, you cannot have a horizontal asymptote. It's one or the other, not both. So we have all of the information needed now to sketch a graph of the function. So we're going to construct our x, y coordinate system. And the first thing that I like to do is lay down the asymptotes. Remember, the asymptotes are like your guidelines for the function. So at negative 2, we're going to have a vertical asymptote. Asymptotes are usually represented by dotted lines. And at y equals 1, we're going to have a horizontal asymptote. And then let's plot our intercepts. So we have a y-intercept of negative 1/2, which will be about there, and an x-intercept of 1 there. Now, if you watch the previous example, I said that the asymptotes are like fences. So if I've got cattle in this field here, then all of the cattle are going to be in this field, okay? And the dots are like cattle. So what that means is, it means I need to connect these dots and make it approach the asymptotes remaining in this field here. The asymptotes are like fences, and so the sections are like the fields. So there's half of the graph done. The other half is going to be either in this field or this field down here. So the way that I'm going to determine where the other part of the graph is I'm going to look at some x values to the left of the vertical asymptote. So going back over here to my table of values, let's look at -3, -4, and -5. Really, you only need to do one of those, but we're going to do 3 of them just for fun because the work isn't that hard. Now, remember we're plugging those back into the function, and the easiest way, I think, to calculate those values is using your calculator. So with our fraction button, we're going to plug in -3 in for both x's. That's going to be -3 minus 1 over -3 plus 2. And that gives us a y coordinate of 4. And then if we do it again, it's real easy to edit these values. Just scroll back and delete and make a 4. And go up, delete, and a 4. Do you see how freaking easy that is to edit your code to generate a new function value? So 5/2, it's easier to plot a decimal, so I'm going to make that a decimal, 2.5. And then for -5, back, delete, change to a 5, delete, change to a 5, is 2. And now let's plot those points and see where the graph is. At -3, we're at 4. 1, 2, 3, 4. So about here. At -4, we're at 2.5. So about here. And at -5, we're at 2. So about here. And so you can see with those 3 points that this graph, remember it has to hug the asymptotes, is going to do something like that. And now that I've completed everything they asked for, I want to check that with Desmos. So here I've input the function f of x is x minus 1 over x plus 2. This gives me a look at the graph, which I can go back here and I can see that it curves down, barely going through the 4th quadrant, and then up here in the 2nd quadrant. And again, see that it cuts off a little piece in the 4th quadrant and then up here in the 2nd quadrant. Now let's check our asymptotes. X equal -2 was our vertical asymptote. And here, if I scroll out a bit, you can see that it really hugs the graph. So this makes me feel better about x equal -2. And then our horizontal asymptote was y equals 1. And again, you can see that that fits nicely, hugging the graph as you go to infinity and -infinity. And then we're going to click our home button to get that back to a standard window. And I want to check the intercepts. So clicking on the graph, 0, -1/2 for our y-intercept, 1 and 0 for our x-intercept. You know what? You can even verify those points we calculated by typing in the ordered pairs. So -3 was at 4. And you see if you plot that point, it'll tell you whether it should be on the graph or not. So that's kind of cool too, that you can even verify these ordered pairs are correct in Desmos. Man, all of this technology, freaking exciting. It's awesome. And I believe that's going to do it for this problem. And that's also going to do it for this lesson. So if you have any questions or comments about anything that I've covered so far, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.